So I want to just finish, I want to finish this lesson first, and then we'll spend time to go over homework. Good? Good.
I'm eating one of them.
Okay. So in the previous lesson, I know it seems like such a long time ago, we learned all the different rules for integration, which were basically working backwards. So for example, like the power rule, we would add one to the exponent and then divide by that new exponent, right? The antiderivative for cosine is sine because the derivative for sine is cosine, right? And then, like, for example, secant squared, antiderivative is tangent, so on. So when we take the derivative of the antiderivative, we get back what we started with. Okay, so here.
Does it matter the order? You have can you take the antiderivative of the derivative, or you have to take the derivative of the antiderivative?
Oh,
Does that make sense?
Usually, I understand what you're asking. It's a little bit different, but if you're talking about just the formula, then yeah, it's the same thing. Whether you do the derivative of the antiderivative or the antiderivative of the derivative, you get back with what you started with. Think of they're inverses of each other. Okay. So when I take d dx, you'll notice here I just have different variables not to be confused. F of t dt, you get f of x. Now, that's important to note that x, this is my, what I call my upper bound. And a, this is just some constant lower bound. No, it is. It's just that you'll see when I do the examples, I need to make sure that when I apply this rule, I have to make sure that my upper bound has the variable in it and the lower bound has a constant. This is just kind of just some notation kind of proving that when I do the integral, so this is kind of important, this conclusion here. So the integral from a to x of f of t dt, we end up with whatever our antiderivative would be. That's when I use the capital letter F. We evaluate that at the upper bound, and then we subtract and we evaluate it at the lower bound. So this is
for antiderivative is a capital.
yeah. Okay. So using that formula, guys. So using that formula, I want to evaluate each of these. So we're going to combine the formulas that we learned in the previous section with using this formula for evaluating integrals. Okay, so the first thing we need to do is think the antiderivative for sine. Okay, so remember from that previous page, if you need to refer back to it, I had them all in that box.
You can just think of it as like
Going reverse.
yeah. Reverse.
Okay, so I put negative cosine.
And we take negative plus pi? Why did you do that?
Okay, so what I'll explain. Again, if you're not sure, guys, the derivative of cosine is negative sine. So that negative would cancel, right? Now I have not done anything except for written. I've taken care of, so as soon as I take care of the integral, and the integral and the dx kind of go together. So as soon as I find the antiderivative formula, I don't need to put that elongated s or the dx anymore. I'm going to put brackets around it to show that I want to evaluate this from 0 to pi. So I just kind of put the bounds at the edge of the bracket. Right. So I'm going to plug in negative cosine of pi minus negative cosine of 0. Okay, so the capital letter F represents my antiderivative. What was my antiderivative? Negative cosine x. So I want to evaluate it. We always evaluate the upper bound. Always put a minus sign here. And then we put negative cosine of 0. So I'm taking whatever that formula I got for my antiderivative. I'm going to evaluate it at the upper bound, and then minus, and then evaluate it at the lower bound.
I don't know if you talked about this last class, I wasn't here, but what about this C? Are we sure?
We don't need
Is
C.
it there?
So the only time we need C is if these bounds are missing. We don't need plus C. If the bounds were missing, we would always put in a plus C at the end. Now on our unit circle, so like here, so this is 0, pi over 2, pi, 3 pi over 2. So I want to evaluate cosine of pi. So cosine of pi, that's my x value, is negative 1. So I have negative 1, if you will, minus. And then negative cosine of 0 would just be a 1. So this becomes 1 plus 1, which gives us 2.
Wait, so many negatives.
Now, we have a way.
Should it not be 0? Like if we get
It
0,
shouldn't be 0. So we have a way that, I would like you to remember how to check. Let me just clear this out. So let's say I want to find, let's see, sine of x. Okay, so if I graph my sine curve, we are specifically, I just put it in y1. And I want to graph from 0 to pi, or that's where I want to evaluate it. So we can go to second, calculate. Remember number 7. My lower bound is 0. Press enter. My upper bound is pi. So it's going to integrate f of x dx from that lower to upper bound, and we get 2.
Wait, how do
So we checked it, we just verified on our calculator that the area under the sine curve from 0 to pi is equal to 2.
Can you do that process one more time from the sine curve?
Do what? Second count, second trace,
Now, and then you go to 7.
7, lower bound is 0.
Upper limit is 5.
Yeah, and just press enter.
Okay.
In other words, I want you to be able to, obviously I want you to be able to do this by hand, but you have a way to check your answers with your calculator. And I told you that the chapter 5 test is all calculator, but you need to know how to, so for example, I'm going to ask you to show this step, but you can use your calculator to evaluate. So you don't need to worry about memorizing the unit circle, for example. Just make sure your calculator's in readings. Okay? Let's look at B. Okay, you always do the upper bound and then the lower bound. Upper bound. Oh no, when you type it in the lower bound, put the lower bound first. Okay, here we get, so this is the power rule. Think x squared. So we increase, so it becomes x to the third divided by 3.
Wait.
So it's 3x to the third divided by 3. Well, the 3's just cancel, right? So I get x cubed. If you don't want to put the brackets, you can just draw a line after it. This just means evaluated.
I get 7 in my fucking values. Should be increased.
It should be in radians.
Yeah, I just switched it to radians. But the value that they give me is 3.75. Brilliant. Then how do I? Oh, I'm
You have
typing
to
the
type
wrong
in,
one.
you have to type in the original.
Oh, you plugged in the original?
Yeah, okay, guys, if you're checking this on your calculator, if you're typing this in, you're typing in the 3x squared, not the x cubed. So if I graph this, that's the curve that I want. And then if I want to check this on my calculator, again, we go to 7, and we went from -1 to 2, and we should get 9. So that means the area under the curve of x squared from -1 to 2 is 9. We just did it by hand, and we did that, to check on our calculator. Are we okay with that now? How about C? Okay, so if I add 1, guys, there's too much. If I have -2 and I add 1, I get -1, right? So it's negative x to the -1, and we divide by that -1.
So it turns into 1 over x. Exactly.
So it becomes 1 over x evaluated from 1 to 2. So it's minus 1 over 1. So we get -1/2. Now, what does that mean when I get a negative answer? It means that more of the curve is below the x-axis. Either the entire curve is below the x-axis, or there's more shaded area under the x-axis than above. That's what that means. Are we okay with that one? Questions? Okay, secant squared. So think, what gives us, when we take the derivative of it, secant squared? Tangent. So that means the antiderivative for secant squared is tangent. We want to evaluate that from 0 to pi over 4. Again, you can use your calculator, it's fine if you don't remember the unit circle. We just want to evaluate tangent at pi over 4 and subtract tangent of 0. So tangent of pi over 4 is 1.
Why? Because it's root 2 over 2 divided by root 2 over 2.
And then tangent of 0 is 0.
Oh,
So we get 1.
tangent.
No, that's tangent of pi over 2 is undefined.
Tangent is sine of 8. So y over
Tangent? Uh-huh. Good?
Did you realize I think the base so you put that on I thought you put them all on balance.
Okay. Average value. So to find the average value of a function over a closed interval, you just do 1 over b minus a. So basically 1 over the integral, and then multiply that by the antiderivative.
Which is the upper bound here
The upper bound is b.
at?
So a is lower bound. So we want to find the average value of f of x equals 4 minus x squared from 0 to 3. So we can evaluate, again, average value is going to refer to a y value. So picture 4 minus x squared. You know what that, it's an upside down parabola, okay?
At 4.
So at 4, so from 0 to 3, so this is going to keep actually going. So picture that, yeah, if you don't remember how to graph it, and I just wanted to try to show you. looking at this curve, so if we can figure out the area under the curve and then multiply that by 1/3, we'll get the average value, the average y value. No?
Why would three?
Because it goes from 0 to 3, so this is A and this is B. So my average value for f is going to be 1 over 3 minus 0, the integral from 0 to 3, of 4 minus x squared dx. So once I solve that, that's going to give me my average value. And then it says at what points. So that means this will be an x value. So kind of where does that occur is the second question. So let's solve for the first part. We get 1/3.
You take the
Okay, so
antiderivative of
4.
minus x.
Think of this as 4x to the 0. So if I add 1, it just becomes 4x to the first. So just 4x minus x cubed over 3. And we want to evaluate that from 0 to 3. Now that 1/3, you could distribute it if you want, but what I would do is just multiply that at the very end. So evaluate it at 3. The nice thing is what happens when we evaluate it at 0? It's just 0. So really we just need to worry about plugging in the 3. So 1/3. So we get 12 minus 9.
9. No, yeah.
So we get 1.
1 minus 0.
So think about that. Y equals 1, that's my average y value, which kind of makes sense. It looks like it's right in the middle between where we started from and where we ended up. Now that's not always going to be the case because sometimes we'll have a more difficult, maybe a trig function or maybe some other type of polynomial. So you want to be able to find that average value. And then the second part is at what point. So basically, what is the x value when my average y value is 1?
Plug it back into the original.
Right, so set original equal to the average value. So I have 4 minus x squared equal to 1. So basically I get x squared is equal to 3. Now, we do plus or minus, but you need to make sure that your answer is in the integral, or in the interval. So the interval that was given,
It's not negative.
so the answer must be on the interval from 0 to 3. So that means x has to just be positive root 3, not the negative. Sometimes you want the negative, depending on which your original domain is given, will determine which answer you want. So you just have to go back and make sure. Questions? We'll go back and when we look at the homework, I know you probably weren't able to get that far with the homework because we didn't get that far in the lesson. This is the mean value theorem. This is what I just showed you.
Wait, can you go up with
More? Why wouldn't what? Okay, so the previous page, I was not looking for average value. I was just looking for the area under the curve. So to find average value, you take that integral and multiply by 1 over b minus a in the front. That's the only difference. That's like the one additional piece.
Yeah, but you don't.
Okay. They were. Both of them, I think. I'll double check. They're on YouTube. I made a page on. I made a page for screencasts on your haiku page. Oh, okay.